For the students who just logged in, um, please log into your Desmos activity and get it ready.
All right. So thank you for those of you that are here and on time. I appreciate it. Just for future reference, in math, your schedule is not going to be any different today, tomorrow, or next Thursday or next Friday. I've already gotten both vaccines, both shots. So you're not going to have any asynchronous work in my class or anything like that because I already went through the motions and got mine. So make sure you double check with your other teachers to see if they have any asynchronous work for any of these 4 days. But math will go on. So earlier in the class, somebody asked if the assessment was graded. Nope. Usually before I post anybody's grade, I get all 6 or all 5 hours done. So that will be either today or tomorrow. All right, so there's several of you that need to be logged into Desmos. So Dina, Zion, Maram, if you guys could log into Desmos, Hussein, log into Desmos. If you're the Hussein that's already logged into Desmos, thank you. All right. So for number one on the bell work, what does parentheses mean?
Multiplication.
Multiplying. So don't let those parentheses scare you. You guys know how to do that. So when you multiply, you know how to multiply numbers. You've been multiplying numbers since third grade. So the big bases, right? The -6 and the 5, you're just going to multiply like always. But what did we learn 2 days ago? What are we going to do to the exponents?
Add.
Yeah, we're going to add the exponents with the same base. So the x exponents we're going to add, and then the y exponents we're going to add.
Miss, your screen is frozen.
I know I'm not going over it yet.
Oh.
I'm still waiting for a lot of you to show work. So I was just trying to walk you through it. Yeah, I'll share my screen in a couple minutes. All right, so for the product rule, I'm just going to write it without the parentheses. Just means multiplying. Now, the work that I need to see, we need to see -6 times -5. What's -6 times -5?
30.
-30. And then the work that we need to see the x to the 4th times x to the 1. When we're multiplying, what are we doing to the exponents?
Add.
Thank you. So I need to see this. There's really a 1 right here. And there's really a 1 right here. So then y to the 1, then 2. Now you don't have to write the multiplication. Symbols, you just put them next to it and you're good to go. All right, what about division? When you were learning multiplying in third grade, you were also learning division. What is 18 divided by 3?
6.
6. Yesterday on the practice, we saw students subtract those two numbers. We saw them add and multiply. When you see that fraction bar, that means division. What do we do to exponents when we divide, though?
Minus.
Minus. And then I start with the top exponent first. So then I have 6x squared and I have yx squared, all in the numerator because there were no negative exponents. All right. Any specific questions on slide number 1?
Yes, how is it 6?
Because you're dividing the bases. 18 divided by 3. That fraction bar means division. If I would put this up here, what's 18 divided by 3? It's 6.
Oh, I thought you had to subtract. I thought we were doing like the opposite.
So this is an exponent rule. So exponents you subtract, but you guys can't forget, the last 6 years of your math career. 18 divided by 3 is just 6. So we got rid of the division bar because there was no negative exponents. So the division bar is technically still there, but since there's nothing underneath except for a 1, we don't need to write it.
If there was a negative, would we still do the same thing?
Well, you have to be specific. A negative what?
Like a negative whole number, not a exponent.
Are you talking about base?
Yeah, like the base.
Yeah, you would still have to divide. If you had 5 divided by negative 15, you still have to divide. You're going to get 1 over negative 3. You're only minusing bases. Look how I write them in the air. I'm sorry, you're only minusing exponents. Look how I'm writing them in the air. That's the only time you subtract. And the reason why, think about middle school. X to the 5th means that. X to the 3rd on the bottom means that. You're crossing these out. How many are you left with? You're left with x squared on top. But please don't show work like that. But that's how you understand it conceptually. All right, if you need any extra help on this, guess what? Virtual learning labs are back. So come at 1:45. All right, slide 2. I'm going to set the timer for another 2 minutes. This is definitely a middle school review. If you don't remember from middle school, there's a little conversion chart. We have a percentage. We need to make it a decimal. So everyone mosey on over to slide number 2, please. All right, Hussein, I need you to be on slide number 2. You'll have to finish slide number 1 on your own time. Ali, thank you. Let's see if Dina's still with us. Nope. Miriam, if you could join us on Desmos, that would, well, Miriam's not here, never mind. Hussein, if you could join us on Desmos, that would be great. All right, about another 30 seconds. All right, thank you for the 12 of you that are writing. Okay, so we have this percentage. We have 85%. What I recommend doing is if you have a percent and you need to make a decimal, just put it in the calculator. If you're not sure, have that trusty calculator. 85 divided by 100 gets you the 0.85. So we can check it right away. What does 60% become as a decimal? 0.6 or 0.60, does not matter, okay? Now you have to be very careful about 3%. What does 3% become as a decimal?
0.03.
Yep, 0.03. Technically, you don't need that front 0, but you definitely need this 0 right here. So if you write 0.30, what does that percent mean? If you write 0.30, what is that as a percent?
0.3. I mean 3.
Well, okay.
0.03.
So 3% is the,
It's gonna be 0.03.
okay, so 3% is 0.03. You have to be careful because 30% is 0.3. These are not the same. We see this mistake every single year. You need that 0 is what I was trying to get at. So just be mindful of that. All right. 7.25. 7.25 divided by 100. Another thing that I notice, students tend to leave off some decimals, some place values. You have to write all of the numbers. So if it says 0.0725, you have to write the 7, the 2, and the 5. You can't just cut it off.
Well, how about for the rest of them?
All right, what is 15.8%?
0.158.
All right, 6.875.
0.06875.
Okay, all of those numbers matter. All right. Once again, you are not allowed to round that. All right, any specific questions on slide number 2? All right, so some of you may be wondering, well, why are we dealing with decimals? Why do we need to convert from a percentage? We are moving on to truly talk about exponential growth and truly talk about exponential decay, which today will be our increasing values. Tomorrow we will do our decreasing. So move to slide number 3, please. And I want you to read slide number 3. All right, so we are now truly talking about exponential growth functions. So for the last 2 weeks, we have done y equals a times b to the x power. So let's talk about this. What is the same between these two equations? What letters are the same?
A.
The a value, yes, that's not going
A.
anywhere. So we have the a and we have the a. What did the b become?
Right.
Y. Yeah, Y.
Nope.
Or
Look
one.
right here. What's right next to A in this equation?
It's one
plus
that
R.
changed.
It's now 1 plus R. So thank you, Rosa. Thank you, Fatma. Yes, the B is replaced with a 1 plus R. So this is how we do exponential in real life, okay? Yes, we do talk about the B value as doubling or tripling, but we talk about percent increase, the rate, and that's where your bell work slide number 2 is going to come into play. So one thing that we wanted you to get is when B is greater than 1, your function is going to be growing. So all of our green, the 1 plus R, is going to be higher than 1. It's going to be like 1.2 or 1.5 or whatever. It's going to be greater than 1. Also notice that the variable, we're not going to type X. We're going to type T because time. We're going to measure things in time. It could be years, it could be weeks, it could be months. So just keep that in mind when we get into these problems. So let's get into an example problem to break it down a little bit. All right, slide number 4. All right, Najim, I need you on slide number 4. Yazin, slide number 4. Everybody else, slide number 4. All right, before you guys start typing, I need to tell you what we're asking of you. So there's really not a lot of work to be had. You can either upload your work, you can sketch it, it does not matter. In this problem, I'm going to want you to identify the A and the R, and then tell what the time is, okay? And we'll talk about that as this problem goes on. All right, so it says the inaugural attendance of an annual music festival is 150,000 people. The attendance Y has been increasing. So increasing, we're going to be looking for those words, by 8% each year. So we said our A value was our starting value. How many people did we start with here?
150,000.
Yep. 150.
150,000.
I don't recommend putting the comma, okay? Now think about our slide number 2. What do I have to divide with 8 to get a decimal, to get rid of the percentage?
100.
100. I'll make that a little bigger for you guys. All right, so in your calculator, 8 divided by 100. It's always going to be 100. And then for our T, are we talking about days, weeks, months, years?
Year.
All right. So now what we're going to do, we're going to write our first equation. Y equals, what did we say our A was?
150,000.
Yep, make sure you write as many zeros. All right, then we have the 1. Now notice that we're adding. It's because we said that we're increasing by 8%. That's why we're adding. Tomorrow we're going to be decreasing. So we're going to be subtracting. What number is my R value that we found?
But we divided it. It's 0.08.
Yep. So 0.08, end the parenthesis, and then the shift 6. And now we're just going to put the t because we're making the equation. Okay, so the equation needs to have two variables. All right, let's check our answer. Cool. Now in this equation, it says simplify. That's our next step. What's the only thing that we need to simplify so far? What can we add together? We have this in parentheses. How do we make it smaller?
You under the parentheses.
Yeah, it's what's inside the parentheses, the 1 plus r. So we're going to be adding the 1 plus r. So we're going to be doing the 1 plus 0.08. So there we go.
Wait, Miss, what did you just do?
I just added the two together right here. Okay. So the cool thing about this now, at least as a math teacher, we finally have our y equals a times b to the t power. Okay, remember we placed the x and the t. It's the same thing. But this 1 plus r became what we're used to. This is what we've been doing for 2 weeks. And notice that our b value is bigger than 1. They told us that this concert population is increasing. So all of these connections, all of these dots make me a happy camper. All right. So just make sure that you're just adding the two together. Now for the next one, this is where scientists, I mean, we're talking about prediction here. This is where scientists or people in the music industry thrive. They want to predict. It says predict the number of people that will be attending in the 5th year. So we have this beautiful equation. Where am I going to put that 5? Where am I plugging that into?
The R.
Look it, we're talking about
I mean,
years.
T.
Look right here, we're talking about years. What variable is our years?
T.
It's our t value. We're evaluating the same thing that we did in topic 3. So you're putting this 5 here. And go to the calculator, evaluate. You're going to put the whole equation in. 1, 5, 0, then 3 more zeros. 1.08, caret key, and then the 5. Now we have to round to the nearest whole number. So we have 220,399 people. Do I care about those decimals?
Yes, I think.
Can we have a decimal of a person?
No.
No,
No. And it's
unless they're
0.2.
dead.
Still a whole person. Just a whole soul now. All right, so we have 220,399. So in 5 years, they're predicting 220,399 people. So all you're doing is plugging in that 5.
Doesn't let me plug it in.
What does it mean to plug it in?
I said it wasn't letting me, but it's because I added the dash. Never mind.
Okay. Yep. All right. We're going to try number 5. Slide number 5. Okay, the first thing we do is identify what is the A value.
3,553.
Okay, cool. The R value, what do we have to do to the 6.2?
Divide by 100.
Thank you. And really, guys, open up this calculator and divide by 100. Miss C and myself can see these calculations. We can see where you went wrong. If you use your phone, we can't see anything. So 0.062. And then here for time, are we talking about days, weeks?
Days.
Yeah, we're talking about days. Okay. All right, now all we're asking you to do is put the information into an equation. So we have y equals, I believe it was Ibrahim that said it's 3,553. And then our decimal. And then raised to the t power. All right, so when I say simplify, what's the only thing that we're simplifying here?
The one in parentheses.
Yeah, the one inside parentheses. So all we're doing, once again, I really think you should just add it here. So then we have the 3,553, 1.062 caret t. All right, it says if this trend continues, how much money could you expect in 2 weeks, which is 14 days? So am I going to use the 2 weeks or am I going to use the 14 days? Look back at our T.
40 days.
Our T is talking about days. So am I going to use 2 or am I going to use 14?
14.
I'm going to use 14. So this is the work that I need to see, either in the calculator or on your sketch pad. So I'm going to put a 14 in the exponent, and then I'm just going to let the calculator do the work. Can't be any easier than this, guys. Now it says round to the nearest whole number. We have a 0.8. So is that higher than 5? 0.8. Is 8 higher than 5? Anybody?
Yes.
Yes. So then I'm rounding that 7 to an 8. So it's going to be $8,248. And then try the last slide. And